Well, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's webinar. I'm Charlene O'Hanlon, your moderator for today's event, and I welcome you. We have a great webinar on tap with some really interesting information, but before we get started with that, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be able to access it on demand. Following the event, we will be sending out an email that will contain a link to the webinar that you can access on demand. And with that, we'll go ahead and get started with today's webinar.
Thanks, Charlene. This is Adam. Thanks for everybody for joining us today. We have hopefully a really good webinar for you. I'm going to kick things off talking a little bit about security in a DevOps model, and I think I'll take a little bit of a different approach to it. So instead of focusing more on the technical side of things, the intent here is to focus on how we established one kind of internally in CIS and how we approached it from a human factors first perspective. Next slide real quick. Thanks, Michael. So a little bit about traditional compliance paradigms, basically. I think you're probably well aware of this, but the traditional compliance paradigm, and I think this is important to look at before we get into looking at the DevOps paradigm and how that helps. The traditional paradigm would have an enterprise establish its information security policy in a way that might be expected to satisfy requirements from a variety of different control frameworks at once. Not every organization is in that position, but there are a few out there who are. And most of those frameworks that help an information security program define their policies, right, are based on this model that looks like what you're seeing here. It's the observe, orient, decide, act loop. What you see here is a little different than that. Because it's really an amalgamation of all the different ways these control frameworks refer to that OODA loop. In ISO 27000, for example, they describe the loop as a plan, do, check, act sequence. And here I've just labeled it as plan and organize, deliver your system security, monitor and evaluate, and improve and adapt. But, you know, I mean, basically all the frameworks you see out there essentially say the same thing. I think we could probably do an entire webinar on that topic alone. But this is really an amalgamation of 14 distinct control frameworks. They all roughly equate to this circle, if you will. And you know, the idea when the idea of being compliant to a more abstract policy, right? The control framework first began, and this is probably, you know, many years ago at this point. I think we were roughly on, at least when I got introduced to it around the year 2000, maybe a little earlier than that, we were on a 3-year cycle to execute this loop. So every 3 years or so, we'd observe the enterprise, basically orient ourselves based on whatever updated information we had, you know, all the changes that were made, all the different risks that exist. We'd make some decisions, take some actions, and then 3 years later, we'd do it again. I think I would be the first to admit that the cycle has improved quite a bit. You know, I don't think we're necessarily on 3-year cycles across the board anymore. I think we've shortened that time quite a bit. But I think audit cycles haven't really caught up to or gotten to the point where it could. So while we may not be on these massive 3-year cycles anymore, we have realized some continuous monitoring gains between the monitor and evaluate and improve and adapt spaces there. Nonetheless, we have these long audit cycles, and they're really predicated, I think, on a siloed, more waterfall mindset. Next slide, please. Thank you. So just for a moment, we'll step away from that traditional paradigm and look more at the DevOps paradigm. So what is DevOps really? And you know, it really comes from the software world, but I think it's applicable to IT operations and security programs equally, especially as we're moving towards everything as code, right? We're even talking about governance as code, which is kind of what this starts to get to. So I think the model is becoming more widely applicable. And really, DevOps is more than just a prescribed set of processes and tools that organizations should be doing, right? It's a cultural change in addition to a technological phenomenon. So the goal really is to build a collaborative, blameless, transparent learning culture that works under what is commonly called the DevOps Compact, at least as we know it. And that's clearly defined shared goals, constant communication, and dynamic adjustment of understanding. So really, it's a recognition that you don't know everything up front. If you plan for everything up front, as soon as you have a change, all that planning kind of goes out the window. And I think what's really important about the DevOps model and what they've seen in the field, at least in software development, and as more moves into code, infrastructure as code, governance as code, is DevOps practitioners have found the most effective ways of implementing DevOps is to have all the responsibilities essentially embedded in a single team, right? So you have a cross-functional team that has all of the disciplines represented in that team with the shared goals, their shared objectives, shared tasks, things that they need to get done. If that can't or won't necessarily be achieved, like if you can't really have a single team that's working together day in, day out with all the disciplines represented, then those multiple teams that seek to have that same outcome, they have to share the responsibilities, they have to share the same goals, and they have to measure their success by the same metrics. It can't be done independently. Next slide, please. Yeah, so what are the real differences between these two things? And I think if you really just look at these basically, right, abstractly, you'll see that OODA and the DevOps cycles aren't really all that different from each other. Each basically has planning involved. They each have implementation steps. They each have maintenance steps, and they both represent a feedback loop. One's a circle, one's a figure eight. What really differs between them in practice, at least, is usually the time it usually takes to accomplish the cycle, right? In DevOps, the cycle could happen very quickly. And in some cases, it happens continuously, right? I think that's the goal for operating software as a service, for example. In the audit cycles and the OODA loop, in that typical environment, it happens much more slowly than that. And my assertion basically is that in the DevOps model, the teams are empowered and accountable. They deliver their product or service with specific requirements, right? So they know what their outcome needs to be. And they're able to speed the execution by leveraging automation, which is an important component of that. Next slide, please. Thank you. Right, so, how do you want to enable your DevOps approach? Like in your security program, in your IT operations, which really have to go hand in hand, right? In your software delivery, we have a few suggestions. I think the first is really important. You want to articulate your security requirements in a code-friendly way. So as an example, when your policy says you need to use strong cryptography on information in transit, which sounds like a pretty typical policy statement, your enterprise standards need to be very specific. So for example, if you're talking about encrypting your web traffic, for example, which TLS versions are actually allowed? Are you going to stick only with 1.3, or are you going to allow version 1.2? And then, okay, you're using TLS, which cipher suites are permitted? Because there are a variety of those available to you. And are there any related certificate requirements that you have to put in place? The more specific you can be with those technical details, the more likely it's going to be that you're able to actually craft that in code in some form. And when it's craftable in code, you can automate it. From the CIS perspective, I think that as we have CIS controls as our control framework that maps into all the others, and we have CIS benchmarks, and those can be tailored to any specific configuration standards you might have as part of your enterprise, that map together, I think that starts to be, it's a good way to start to achieve that, getting down to the specifics that you need, at least from a configuration management perspective. I've mentioned before, you want to create these cross-functional delivery teams that keep the quote customer representation in mind. And when I put customer in quotes, because not everybody has like an external customer to the company or to the organization, but everybody has a customer. Everybody has somebody who's relying on the service or product that they're providing. And if you can provide that cross-functional delivery team, you're starting to approach the human problem, where it really takes a team of like-minded individuals with varying degrees of skill in different disciplines to fit the bill, essentially, to deliver the outcome you desire. Thirdly, you want to empower your delivery teams, and this is incredibly important. Empowering the team doesn't mean you just give them carte blanche to go do whatever they want. Yes, you have to still hold them accountable. But given the first suggestion of articulating your security requirements as technically as you can, as specifically as you can, this should be an easier thing to accomplish. And that's usually where we get into problems of tossing work over the wall, right? But essentially, you empower your delivery team. You want them to essentially own the responsibility of information security. It's far more effective for the long run when the team feels that ownership. So yeah, using team-based tools is a good way to empower your teams in this regard. So you can think about that as you're selecting the products that you want to use. The fourth thing on the list is thinking iteratively, and I think a corollary to that is essentially allow for learning, which is another way to say failure is okay, right? So if we stop thinking in terms of waterfall, where we have to have all the answers right up front and then toss something over a wall and then they figure some things out, but then when they have challenges, we toss it back over the wall. And we start thinking more iteratively and cross-functionally, things are inevitably better, right? Small changes are far easier to develop. They're easier to deploy. They're easier to troubleshoot. And I think an additional benefit is that because you didn't take all the time up front to try to plan out every detail, when the inevitable change comes, you're being more efficient, right? You're better prepared to handle that. The final thing on this list is really maximizing CICD wherever you can. And I think all the previous items sort of lead up to this. Your product or service delivery teams should really maximize their CICD capabilities. It's a winning combination to have concise security requirements built in to an automated continuous integration and continuous delivery service. Part of the benefit of that we've seen actually is it's easier to audit things. It's easier to get the audit evidence, if you will. So when you have an auditor come in and say, well, where are all the checks and balances, so that I know that when a developer checks in code, that they can't also necessarily affect production directly, right? There's always some checks. The pull request, for example, was peer reviewed as a basic check. It's gone through a rigorous integration testing framework that catches some of the things and does your dynamic and static analysis and all of those sorts of things. You can prove all of that just comes out of your infrastructure. You already have it all written down, and you don't need to go hunting for your answers. So essentially, why DevOps here? So to wrap up this portion of it, and then I'll get into a little bit about the actual way CIS went about building that into its own processes internally. DevOps from a software development perspective, and again, I believe this is transferable to IT operations. We want our engineering teams to be missionaries, not mercenaries, right? And that's actually a phrase that I picked up from a gentleman by the name of Marty Kagan. He's a leader in product management circles, but I think it's relevant here. And he would basically say, teams of missionaries are engaged, they're motivated, they have a deep understanding of the business context and a tangible empathy for the customer. And I think that's the type of team that we want helping our security programs. It's the type of team we want who owns security, who's actually just on the front line, really delivering the services to either the organization or the customers. Mercenaries, on the other hand, are really, they don't feel a sense of empowerment or accountability. They don't necessarily have passion for the problem to be solved. And they have little real connection with the actual users and customers. Next slide, please. Thank you. So, you know, the last bit, the missionaries versus mercenaries, really does speak, in my mind anyway, to the human problem. It's about humans working with other humans. We want our delivery teams, our product teams, our service teams to feel real ownership and to not necessarily view security requirements as a burden, as a constraint, but as something that they own and believe in. So what we have what we have done at CIS, is we convened essentially an integrated project team, and that took a few different resources, a few different people from around the company, brought them together, and gave them some outcomes that we wanted to see. So in order to get to those outcomes, what we ended up doing was bringing in, we have a community of practice internally at CIS for software development. And we brought in the community of practice, shared with them what the outcomes, desired outcomes were. And through an iterative process that lasted, I mean, in the grand scheme of things, it wasn't that long. It really was only about 15 weeks, 16 weeks. We ended up mapping out that DevOps figure 8 into 3 categories, 3 generalized categories, if you will, of agile product planning, development, and launch and monitor. And from that, we were able to get each delivery team within the company to map into those categories, how they did their work. And we were able to craft an initial policy and arrive an initial set of standards that then became kind of the blessed policy. So what we have now is a solid DevOps model that addresses our security needs. And this is the important part, with the buy-in of the teams that are being held accountable for effecting those security needs. Right, they're engaged with it, they bought into it, they helped define it. So it really ended up well for us. So we now have a DevOps framework that's rooted in company policy, that has the full backing of those delivery teams, as well as executive leadership to include the CISO, the CIO, the CEO. And it's been a really great process. It's been a great outcome for us so far. So next slide. Oh, yeah, okay. So yeah, that's concludes my portion anyway. So I appreciate your time as usual, and I'll hand it over to Michael.
Thanks, Adam. So Adam's the Chief Product Architect for the Center for Internet Security. So great to hear firsthand Adam's perspective on DevOps and also how they're doing that at CIS. So leading on from that discussion, I'm going to be talking about cloud operational excellence and how to build guardrails or use guardrails to build exceptional architecture and avoid misconfigurations. So my name's Michael Watts. I'm the Vice President of Product Management for Trend Micro. Prior to that, I was the co-founder and CEO of Cloud Conformity, which was acquired by Trend Micro in October last year. So we'll be giving you some thoughts around how we have been doing this for customers and giving you some real world examples. So let's take a step back though and remember why traditionally security is so difficult in an on-premise world. So typically it's difficult for organizations to know what resources and data exist at any given time, where the data is moving to, and who's accessing it. Most organizations also don't have the level of visibility that they would like in an on-premise environment. Without that visibility, it's obviously going to be challenging for the organization to adequately secure their infrastructure and data and really to meet their security and compliance requirements. There's also usually a low degree of automation and Adam touched on that. If everything's manual, it's always going to be a serious challenge to get everybody working on the same page and do things in a consistent manner. So think about things like copying and pasting information from one tool to another, or manually applying patches, which we know can take a serious amount of time. And once you do it, you have to do it again. So these manual processes tend to lead to inconsistent execution, longer wait times, and in most cases, it's really disrupting the customer experience, which we all know that customer experience and customer expectation is just rapidly evolving. Customers expect continuous delivery, no downtime, and it really just to be simplistic from the user interface perspective. But that's not to say if you move to the cloud, it's automatically going to solve your security challenges. Unless you're leveraging the full power of public cloud, inevitably you're going to face those similar challenges. So there's going to be the lack of visibility around what resources exist, what they're being used for, and obviously in that cloud environment, that can be rapidly changing. So you need that real-time visibility. There can be critical misconfigurations in the cloud resources, and you'll see in a few slides' time, and you've probably seen in the press pretty consistently, those critical misconfigurations, your S3 buckets being open to the world, can have a serious impact and expose some really critical data. And also you can end up with a plethora of tools, tool sprawl that can be really inconsistent. There's no collaboration or sharing of information, and it's really difficult to jump between those different systems to get that bird's eye view of what you have, what it's being used for, and the understanding of whether your critical systems are secure. So how do we actually go and solve that, knowing that not only cloud is secure out of the box, but once you start building your architecture, there's any number of ways you can architect systems depending on the application. And you can see here that's made even more difficult with the rapid growth in the number of services provided by the cloud providers. This is just AWS, and you can see from 2013, which doesn't seem like that long ago, there was 25 services, and now we're well over 200, and that's just for one cloud provider. And we know that typically organizations now are using that multi-cloud environment, not only for cloud, but also the hybrid cloud with on-premise. So this becomes infinitely more difficult, and obviously we want to provide our teams and our business units with the flexibility to architect their infrastructure using different services in line to give the best customer experience. And we don't want to stifle that with security requirements, and that's where the automation building into that DevOps cycle can be really powerful. Just in case there wasn't enough incentive to actually take security seriously, build this in an automated fashion, repeatable into the CICD pipeline. There's also things like GDPR and the fines associated with breaches these days. So this slide is 2019, so already a year out of date, but you can see the number of fines increasing. The total amount of GDPR fines today over 100 million euros, and some really significant fines. And not only the fine, but the actual impact to the brand. So I'm sure that these organizations are sick of being included in these slide packs, but Time Warner is just one example. 2 misconfigured S3 buckets in AWS, very quick and easy, very simple to do, exposes 4 million personal records. Very difficult to recover from that from a brand perspective, and in this day and age, pretty simple to catch if you have these automated systems to constantly provide the visibility of your infrastructure and show you any misconfigurations that may exist. So how do you move fast and stay secure? It used to be move fast or stay secure, and now organizations should be able to move fast and stay secure. But how do you do that in a cloud world, multi-cloud, utilizing the new services, giving the flexibility to the teams to manage their own infrastructure as well as build their applications, and enable the DevOps or the Cloud Center of Excellence to build guardrails into the various systems and processes that enable anybody to utilize cloud and do it in a repeatable, secure fashion. So AWS have come up with the WellArchitected Framework, which I'm sure most of you have heard of it at some point, giving you a group of standards and controls to architect your infrastructure in line with security, reliability, performance efficiency, cost optimization, and operational excellence. And if you can follow these controls, you can architect your infrastructure in any way, whether you're using traditional servers, relational databases, load balancers, or you're going down a container serverless model, or using the multi-cloud environments, and do this in a repeatable way. This is obviously quite challenging if you're trying to do it manually. You just spot check your infrastructure once a month. That is in no way, shape, or form going to give you adequate security, given the speed of which your cloud infrastructure probably is and should be changing. And then the other consideration here is everybody's journey is different, and that depending on the stage in which you are in that cloud migration or cloud journey, you're going to have different outcomes and different security requirements. So cloud curious, we've probably all been there, maybe a few years ago now for most of us, but you're just maybe doing a lift and shift. You've got a non-critical environment in 1 or 2 AWS accounts or a couple of Azure subscriptions. And at that point, you don't have any critical infrastructure. So it can be, you do a spot check, you use some of the native tools like Trusted Advisor, or you're piecing together some open source technology. But once you start to get to cloud ready, cloud first, cloud native, or ideally that cloud disruptor, that's where you need to start to bake this into your automated process. Ideally shift left into the infrastructure as code, and not be relying on your cloud engineers to be spinning up resources and configuring these things manually, and hoping that every engineer knows every single best practice in the cloud. I'm yet to meet anybody that actually can say they do that, even if they have the 9 or 10 certifications. But everybody's moving towards that left-hand side, and the further you go, the more important it is to have the automated process, bake this into the CICD pipeline, and be effectively putting those guardrails in that allow any engineer to have the freedom and flexibility to actually utilize the cloud to deploy their architecture. So this is an interesting stat that Gartner put out, that through 2023, at least 99% of all cloud failures will be customers' fault. And we see this today. I mean, the shared responsibility model that pretty much all of the cloud providers have in some way, shape, or form is, the responsibility of the cloud versus responsibility in the cloud. And effectively, once a customer starts using the cloud architecture, they're responsible for ensuring that the best practice is followed, depending on the different configurations and different architectures they have in place. And like most customers, application or system A is probably using a different architecture and different services than application B, and maybe even a different cloud provider altogether, or a combination of cloud and on-premise. So unless you can actually have that rigorous, continuous visibility of all of the infrastructure, an understanding of what's acceptable depending on the architecture, and have those organizational policies in place, inevitably there's going to be misconfigurations and potential security concerns that are introduced through lack of understanding and lack of visibility. So we can do this at the infrastructure layer, and we can have a tool like Cloud One Conformity, surfacing up all of the infrastructure in real time, showing you all of your S3 buckets, your EC2, RDS, your Azure blobs, what have you, and giving the engineers the freedom and flexibility to understand through the real-time visibility of what infrastructure do they have, what's it being used for, and is it secure? But how do we do this at a point where it can be baked in and shift left into that CI/CD pipeline, and you're catching these misconfigurations before they're in production? It's great to know that you've got an S3 bucket that's open to the world 20 minutes after it happened, but if you can catch that before it's introduced, that's the holy grail. And in a way that the engineers don't necessarily need to know all of the best practices, but they've got the tools, notifications, and processes in place via the Cloud Center of Excellence and the organizational policies, that as they're checking in their code or as they're making a change, it's a natural evolution that they're getting a response to say, change this line, you've got a misconfiguration here, if this goes to production, this is going to be the impact. And I think that's where the true power of public cloud can be leveraged, with the understanding and I guess the comfort level from the CISO and the management team that those organizational policies are going to be guarding or guardrailing all of the different engineering teams, depending on the criticality of the environment. So some of those things I mentioned. So the rapid growth in new cloud services, this is not going away. And this is the value of using the cloud. We want the cloud providers to be innovative, releasing new services, evolving the existing services, and providing new ways to delight our customers. And that's through the evolution of the technology. But it's impossible to expect all of our engineers and all of our teams to be cloud experts across 3 or 4 different cloud providers, hundreds of different services, and so many different variations of cloud architectures that can be used to deliver the same outcome in a different way. And then also just the lack of visibility. I'm constantly speaking to cloud users or cloud prospects and customers, and one of the first conversations we have when we meet a potential new customer is, how do I actually get that visibility across potentially hundreds or thousands of accounts, hundreds or thousands of engineers? What infrastructure do I actually have? What's it being used for? How often is it changing? And what's my current risk? And that can be a daunting experience. You plug in the necessary controls and you get potentially thousands of misconfigurations and thousands of areas for improvement. Where do you start? How do you start to build those organizational policies? Put the guardrails in place through a team that's centrally managing what is and isn't acceptable based on the stage. So is it testing, staging, non-production, production, and the criticality of the environment and the regulatory controls. This is where that cloud center of excellence comes in place, and they can remove the burden from the application teams and the engineers, and they're responsible for building their infrastructure, but they have that overarching set of controls that can guide them to ensure that these misconfigurations aren't exposing sensitive customer data. So this can be done in a number of different ways, but the crucial components are going to be the centralized visibility and real-time monitoring of the infrastructure. That real-time component is super critical. We all know what can go wrong in 30 minutes or an hour or 24 hours, which is just unacceptable in this day and age. You need to automate these guardrails. It needs to be reliable and scalable. Doing a monthly spot check or a monthly audit or a weekly audit even is no longer applicable in this day and age. And high risk violations need to be instantly detected and auto-corrected. Ideally, you want to catch them in the infrastructure as code or in the CICD pipeline. But if it's happening in the live environment, they need to be self-healed or auto-corrected. And this needs to be built into that DevOps CICD pipeline through powerful APIs. This should be caught early on, particularly as you continue that journey and you get towards the cloud disruptor. There's no point changing in your infrastructure and then you've got a blue-green deployment which pushes the misconfiguration back in because it wasn't fixed in the source. So here's just an example of a customer that started using Cloud One Conformity, these 600 controls running in real time, baked into the CI/CD pipeline. As I mentioned, it can be a little overwhelming. You plug in all of your infrastructure, you're at 60% compliance, you've got some critical misconfigurations, and you potentially have hundreds, if not thousands, of areas for improvement. But this is where the actionability of the system, the self-healing, the fact that this can be automatically corrected over time once you build those organizational policies. And we typically see within the first 3 to 6 months a significant increase in the compliance score. And that could be aligning to a regulatory compliance like PCI, HIPAA, ISO, or it could be just a set of organizational controls that the customers put in place for different criticalities of environments. And the different teams are working to slightly different parameters based on the architecture or the infrastructure that's supporting their applications. So just a great way for an organization, a management team, a cloud center of excellence to put in place some goals for the different teams and the different architectures based on the data and the systems and the criticality. But here's where I think it gets super interesting. So it's great to get the visibility. It's great to have organizational policies. It's great to have the reliability and the scalability, regardless if you have 100 resources or 1 million resources, a small team of engineers, or you're a very large enterprise. How do you put this into the CI/CD pipeline? How do you shift left and save a significant amount of time and effort and money by baking this in early and often and making sure that it's automated? So with this example that we have here, conformity can be running in production across all of your infrastructure, giving you that consistent view of what's happening, is something changing, and what's the impact of the change. But this is where we can get, I think, really cool, plug it into your infrastructure as code via the API. So what we're calling it our template scanner. So effectively, one of your engineers is checking in a change to one of your CloudFormation templates or a Terraform template. The conformity API is pulled, it scans the template, and it identifies that there's a S3 bucket that will be open to the world, and it can automatically break the build. And depending on the implementation model, you could have that automatically break the build and send a notification back to the engineer, or create a Jira ticket or a ServiceNow incident, or it can just be the command line validation as they're doing it on the fly. So really a great way not only to bring up to speed and educate the engineers that are building these templates or managing the infrastructure, but also a great way to catch these things early and often. So by the time you're scanning and viewing the infrastructure that's in the live environment, you already caught the large amount of critical misconfigurations that there's no tolerance for in the organization. And then you're looking more at cost optimization or reliability or performance efficiency, and some of those, what I would call the nice to have when you get through the critical things that typically pop up in cloud infrastructure. Always good to bring these things to life with a bit of a case study, customer story. Large healthcare provider in the US, large enterprise. Like most organizations, they're moving to the cloud. They're a few years in, and now they're looking at building this into their cloud center of excellence. How do we get beyond the spot checks and covering off just the OWASP top 10 or the nice to have low hanging fruit? How do we build this into an automated fashion, build it into our CICD pipeline, have the 600 controls, not only checking for best practice, but their regulatory controls like HIPAA, and automatically ensuring that the right engineer and the right application team is notified based on the infrastructure that they're managing. So conformity has been put in place. It's scanning all of their infrastructure. They've got a centralized visibility and repository for the Cloud Center of Excellence team, and then it's pushed out to the individual engineering teams based on the infrastructure that they manage via the preferred channel. So some of their teams are using Jira, some of them are using ServiceNow, some like to use Slack, and they're just picking up the misconfiguration data as it occurs in their preferred channel with all the information they need to remediate, and then they're starting to build that into their CI/CD pipeline for infrastructure as code as well. So just a really great story to see them quickly evolve their cloud maturity and fast track their migration through consolidation, organizational policies, and building this data and insight into their CI/CD pipeline and enabling their engineers to be completely simplistic. And what are the last I'll leave you with here? Even those cloud disruptors, we looked at the cloud journey and how it varies depending on the organization. Large technology companies, you can see definitely on the right hand end there in the cloud disruptor, automation everywhere, still using these 600 best practice policies built into their CI/CD pipeline. Everything's infrastructure as code, and it's just enabling them to focus on building that next environment versus looking at how do I manage security and compliance in my CI/CD pipeline, in my infrastructure as code, outsourcing that to a tool like Cloud One Conformity, giving them the peace of mind that their regulatory compliance standards are in place, their engineers have the guardrails, the freedom and the flexibility with the oversight of all of these controls running in real time, and providing them with the actionable insights, either automatically built into the CI/CD pipeline or in their live environments via our real-time capability. And with that, I'll leave you with, I mentioned Cloud Conformity was an acquisition of Trend Micro. It's now part of Cloud One, which is the flexible, automated, all-in-one cloud security platform for cloud builders, and really simplifying the number of tools required and bringing it into one powerful platform. With that, I thank you for your time and look forward to the next webinar.
All right, great webinar. Lots of great, interesting information. So I did want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or you just want to listen to it again, just know that you'll be able to do so on demand. We will be sending out an email that will contain a link to the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always check there. And then while you're there, you can check out the other webinars that we have both upcoming and on demand. Hopefully there'll be one or more that pique your interest. For now, though, I'd like to thank you for joining me today, and thanks to our esteemed panelists for joining me. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.